Assalamu alaikum everyone. Dear students, let's move to the next part of Chemical Kinetics chapter. Now in this part, we will discuss some numericals on half-life and rate constant of first order reactions. In previous class, we have derived the expressions for rate constant of zero order and first order, and we have find out the relationship of half-life for different ordered reactions. तो यहाँ पर न्यूमेरिकल्स आते हैं फर्स्ट ऑर्डर रिएक्शंस के हाफ लाइफ के ऊपर और रेट कांस्टेंट कैलकुलेशन के ऊपर। चलिए देखते हैं। फर्स्ट फॉर्मूला लिख लेंगे। व्हाट वी रिलेशनशिप्स वी यूज फॉर कैलकुलेटिंग हाफ लाइफ फॉर फर्स्ट ऑर्डर रिएक्शन। हाफ लाइफ टी हाफ is given by the formula T half is equal to 0.693 divided by K, right? Where T half is half life and K stands for rate constant. Remember this value 0.693. Don't get confused. Sometimes you will be writing 963 or 369. It is 0.693, right? And to calculate rate constant or the completion of reaction at other intervals of time, we use the formula K is equal to 2.303 divided by T log of R naught by R, log of R naught by R, right? K is rate constant, R naught is initial concentration or amount of reactant left out after time t, right? So these two relationships or formulas will be used for calculating the numericals, right? Let's begin. Calculate the half-life of a first order reaction whose rate constant is 200 per second. Now in the question you are asked to calculate what? Calculate the half-life, means T half has to be calculated. Okay, what is given? K value is given. K is equal to 200 per second. Okay, what is the formula? T half is equal to 0.693 divided by K, right? So K value is given, you can substitute 0.693 divided by 200. Okay, 0.693 divided by 200. You will be getting the answer as 0.003465. As we are calculating half-life unit is in again time. That is whatever unit is given in rate constant per second है तो यहाँ पे आपको मिलेगा second. Unit will be second. So time is the unit for half-life. Okay, it can be given in minutes, it can be given in months or years, right? So this is the way you have to calculate. इसको अगर आप साइंटिफिक फॉर्म में लिखना चाह रहे हैं तो 1 2 3 तीन डेसिमल आगे कर दो राइट साइड 3.465 into 10 raised to minus 3 second, right? So this is the way how you have to calculate the half-life when rate constant is given. Okay, so you try by taking calculate the half-life when the rate constant is given to you. I will give one more. K value is 20 per year and one more K value is 500 per minute. ओके, ये जिस तरह हम कैलकुलेट करें, you calculate half-life by taking k value as will be as a homework, and you have to WhatsApp the correct answer on my WhatsApp number, right? Next, a first order reaction is found to have rate constant as 5.5 into 10 raised to minus 14 per second. Find the half-life of the reaction, right? K value is given to you. It is 5.5 into 10 raised to minus 14 per second. You are asked to calculate what? Half-life. Again, the same. T half is equal to 0.693 divided by K. That is equal to 0.693 divided by, what is the K value given? 5.5 into 10 raised to minus 14, right? So 0.693 divided by 5.5, you will be getting 0.126. Okay, and this, when you shift to the numerator, it will become 10 raised to 14. Okay, or you can write 1.26 into 10 raised to, डेसिमल राइट साइड शिफ्ट हो गया, पावर कम हो जाएगा, it becomes 13. Unit will be as it is per second, and here it will be unit as second. Okay, this is the answer, right? So 2 marks questions will be asked based on half-life calculation. Okay, you have to write the correct formula, correct substitution, and final answer with unit should be there. If you are writing the final answer without unit, no marks will be given. Okay, next question. 60% of a first order reaction was completed in 60 minutes. When was it half completed? Right? 60% of a first order reaction was completed in 60 minutes. When was it half completed? Again, they are asking when was it half completed, means they are asking to calculate T half. Nothing but time required for 50% completion they are asking. Okay. But here they did not mention K value. Rate constant is not given to you. If rate constant was given, then directly you would have calculated T half. But rate constant is not given, so you have to calculate the rate constant first. Then you can go with half-life. But they have given 60% of first order reaction was completed in 60 minutes. Right? Means time required for 60% completion. It has been given, that is equal to 60 minutes. ओके, तो जब इस तरह के क्वेश्चंस आते हैं तो आपको इनिशियल आर नॉट वैल्यू जो होता है, आर नॉट स्टैंड्स फॉर इनिशियल कॉन्सेंट्रेशन, यू हैव टू टेक इट एज 100, एंड आर स्टैंड्स फॉर amount of reactant left out. R is what? Amount of reactant left out. रिएक्शन होने के बाद जो रिएक्टेंट बचता है वो वैल्यू क्या है? R, राइट? तो रिएक्शन कितना हो गया है? 60% हो गया है. कितने मिनट्स में? 60 मिनट्स में. तो रिएक्टेंट पहले कितना था? 100%. खत्म कितना हो गया? 60%. तो बचेगा कितना? 40, राइट? तो R is nothing but, we also write it as A minus X. We write it as what? A minus X. So A is initial concentration and X is the amount of substance reacted. तो ये हम लेंगे 100 और ये लेंगे हम 60. तो बचेगा कितना? 40. तो राइट, जब भी आपको R कैलकुलेट करना है, इनिशियल में से कितना रिएक्ट हुआ सबट्रैक्ट कर लो, आपकी R की वैल्यू मिल जाएगी. So R is nothing but 40. So substitute these values in the integrated rate equation of first order reaction, then you will get the K value, the same k value you can use for calculating t half, right? तो शुरू करते हैं, पहले k कैलकुलेट करते हैं. k is equal to 2.303 divided by t log of r naught by r, right? So 2.303 divided by how much is the time given now? t 60% है, तो 60 minutes यहाँ पे लिख देंगे. It is given 60 minutes. Log of r naught value is 100 and r value is 40. Okay, so when you calculate 100 divided by 40, when you do, you will be getting 2.303 divided by 60, you will get 2.5. 100 divided by 40 will be 2.5. Log of 2.5, you have to check the log of 2.5. You have to refer the log table. So single digit is there, so characteristic will be 0, and the mantissa you have to use the log table to check the mantissa. So 25 under 0 आप log table में देखेंगे, जो कि आपको वैल्यू आएगा 0.3979, right? So 2.303 divided by 60 multiplied by 0.3979. For CET and NEET examination, they may give the log values in the question itself, or questions will be in such a way that those log values can be easily remembered. That's why you try to remember log of 10, 20, 30, 40, 50 up to 90, right? Once you know these values, direct substitution can be given without referring the log table. कोई in between values के log value के numerical CET NEET में नहीं आते हैं, right? If they are asking also, they will mention the log value. Okay, so log of 2.5, you will get 0.3979. So when you solve it, you will be getting 0.916 divided by 60, and you will be getting 0.0152, right? So this will be the value of k, and it will be in per minute form, as half the time is given in minutes, so rate constant will be in per minute. So this is the value you got for rate constant. You can write it as 1.52 into 10 raised to minus 2 per minute. Okay, now you got the value of k. Now you can use the half-life formula. T half is equal to 0.693 divided by k. 0.693 divided by k value is how much? 1.52 into 10 raised to minus 2. डिवाइड कर लो, देखो कितना आएगा. 0.693 divided by 1.52. You will be getting 0.4559 into 10 raised to 2. न्यूमरेटर में जाएगा तो 10 raised to 2 हो जाएगा. So you can write 2 digits here, so it will become 45.59, or round off you can write it as 45.6 minutes. 45.6 minutes. Okay, so this is the way you have to solve. Okay, first you have to use the integrated rate equation to calculate the rate constant, then you can go with half-life. Okay, we will have one more question of the same type. 80% of first order reaction is completed in 40 minutes. Calculate half-life, that is T half. Calculate half-life. 80% of reaction has completed in 40 minutes. You are asked to calculate T half, right? Again, what are the things you have to find out over here is you need to find out what the rate constant, then you have to go with half-life. So R naught what you will take, कभी भी आपको R naught वैल्यू लेना है 100 because initial concentration will be 100%. R वैल्यू कितना लेंगे अभी, 80% reaction has completed. What will be left out, that will be nothing but 100 minus 80, it will be equal to 20. Okay, time, 80% reaction is completed in 40 minutes. So K has to be calculated and then you can calculate T half, right? So again, write down the rate constant expression. K is equal to 2.303 divided by T log of R naught by R, right? So 2.303 divided by time, how much is given? 40 minutes. 40 log of 100 divided by 20. Okay, so 21s are 25s are log of 5, 2.303 divided by 40 into log of 5 यानी कि 50 का log वैल्यू लेना है, सिंगल डिजिट 5 है तो कैरेक्टरिस्टिक आता है 0 और 50 अंडर 0 याद रखो, इट विल बी 0.6990, राइट? सो log of 50 is 0.699. सो मल्टीप्लाई करके डिवाइड कर लो, देखो कितना आता है. सो 2.303 into 0.699, you will be getting 1.6097 है, तो आप उसको 61 लिख सकते हैं. 1.61 divided by 40 divided by 40, you will be getting answer as 0.0402. This is the value of K. Unit will be half, the time is given in minutes, so unit will be per minute. Unit क्या आएगा? Per minute, right? इतना फाइनल वैल्यू आप कैलकुलेट करके सब्सटीट्यूट कर सकते हैं या फिर यही पार्ट टी हाफ के फॉर्मूले में भी आप सब्सटीट्यूट कर सकते हैं. जो आपको इजी हो जाएगा वो मेथड आप फॉलो करो. कैसे? अब जैसे आपको ये हाफ लाइफ का वैल्यू, रेट कांस्टेंट का वैल्यू मिल गया है, यू राइट द हाफ लाइफ फॉर्मूला. टी हाफ इज इक्वल टू 0.693 divided by K. So K, instead of final calculation, you can write the same thing over here, 0.693. लेकिन ध्यान से करना है, यहाँ पर आपको जो है वैल्यू जब सब्स्टिट्यूट करते हैं, क्योंकि रेट कांस्टेंट डिनोमिनेटर में है, ये पूरा पार्ट रेसिप्रोकल हो जाएगा, राइट? इट विल बिकम रेसिप्रोकल. सो डिवाइडेड बाय 2.303 इंटू 0.699 और यहाँ पे न्यूमरेटर में आएगा 40, राइट? तो ये इतना पार्ट कितना होगा आपको, अभी हम कैलकुलेट करें, यही आता है. When you calculate, what happens? 0.693 into 40 27.72 divided by 2.303 into 0.699. It will be 1.61, ये वैल्यू, राइट। सिर्फ क्या किया हूं मैं, 40 यहाँ पे 0.693 के साथ मल्टीप्लाई किया हूं, तो आपको क्या आएगा 27.72 divided by 1.61. You will be getting the answer as 17.21 minutes. T half is how much? 17.21 minutes. Okay. या फिर डायरेक्ट सब्स्टिट्यूशन कर लो, T half is equal to 0.693 divided by, कितना मिला आंसर यहाँ पे 0.0402. 0.693 divided by 0.0402. You will be getting the answer as 17 point, थोड़े डेसिमल वैल्यूज वेरी हो जाएंगे, 17.2 you can write minutes. Okay, so both ways you can go. Either you calculate the complete value of k, then substitute in half-life formula, or whatever in between part is there, about to calculate part, ये अभी कैलकुलेशन करने का पार्ट है, तो वो पार्ट डायरेक्टली आप यहाँ के बदले रिप्लेस कर सकते हैं, बट यू हैव टू डू इट वेरी केयरफुली, राइट। न्यूमरेटर से डिनोमिनेटर शिफ्ट हो गया, रेसिप्रोकल नहीं करे तो पूरा रॉन्ग हो जाएगा। ओके, so this is the way you have to solve the half-life and rate constant numericals. Okay, some more important relationships are there that we'll discuss in next session. Okay.